Hey there, Mr. Weaver here with topic 2 and 3, lesson 4. And we're going to begin graphing our functions. After this lesson, you need to be able to create a table for a function, use that table to graph a function. You need to be able to determine if a coordinate is considered a solution to the function. And you need to be able to continue to describe the meaning for parts of our function in context. After this lesson, you'll know you're successful if you can create tables for the functions, graph the functions using the table, decide if coordinates are solutions, and provide meaning in context. First, let's focus on our goal to create a table for a function. When we're creating a function table, our end goal is to create a format so we can have coordinates that we can end up using to graph. So here we have a word problem. Dunkin' is selling medium coffees for $2 each. DoorDash charges a $3 delivery fee. For a situation like this, what we're going to end up doing is trying to figure out a pattern so we can predict how much it will cost for any number of coffees in this situation. So first, let's pick out some information that we know. So we know that coffee is $2 each. So I'm going to write that as 2x, where x is my number of coffees. Then, no matter how many coffees we buy, DoorDash charges an extra $3 for delivery fee. So our function here is going to be 2 for each coffee plus $3 extra. So I'm going to write that in my function notation as d of x equals 2x plus 3. I can use this equation to calculate how much it's going to cost for any number of coffees that I buy. So if I want to know how much it costs to buy 20 coffees, I can plug that into this equation and figure it out. In that same line of thinking, that is what we are going to do here in our function table. So the other piece of information they give us is our domain is -1, 0, 1, 2, and 3. Now, when we think about what the domain means, that's your input values. And in this situation, we couldn't really have -1 coffees. However, I'm including it here because I want you to get the gist of what's happening. So that domain, those are your x values. So we're going to put them in our table as our x values. In order to figure out my f of x or my y value, all I need to do is take each of those domain values and plug it into my function to see what comes out. So if I plug in -1 into that function, 2 times -1 plus 3, simplify it, what ends up coming out is 1. This would tell you that if you bought -1 coffees, it would cost you $1. Again, that doesn't make sense in this context, but it's included there so you can get the pattern. So next, we could try each of the others. So I could plug in 0 into my function, 1 into my function, and I would end up with these values. So 2 coffees plugged in would cost $7. The last part of making a table is creating coordinate points from it. If you remember from the last lesson, the coordinate point is just x and then f of x, and f of x is the same as y. So I just take my two numbers here and put them together as a coordinate. So -1, 1. Following the same pattern going down, I would end up with my coordinates 0, 3, 1, 5, 2, 7, 3, 9. Again, to get that, I took my x value, plugged it into the function, saw what I got out, used those two things together to make my coordinate. Now it's your turn. Pause the video and do the first two sections of the student does side. So write your function for Starbucks coffee and then fill in your table using your domain and your range and create coordinates out of it. We will check your answers at the very end. Next, you need to be able to graph a function using our table and determine if a coordinate is considered a solution of the function. To graph our function, we are going to just take those coordinates we just created and plot them on our coordinate plane. So -1, 1, so 1 to the left and 1 up would be plotted there. 0, 3, 1, 5, 2, 7, and 3, 9. This is what the graph of our function would look like. Notice they are starting to form a straight line. This is good because in this section, all of the functions that you should be graphing and creating should make straight lines. The other part to this is determining if an ordered pair is a solution to the function. So would 9, 19 be a solution to our function d of x? There's a couple different ways I could check. I could attempt to keep plotting some more points on my grid, and hopefully it's making a straight line, but this isn't the best way. It might work for close numbers, but what if I wanted to know, like, if 100 and some value was a solution? It's not going to be very reasonable to try to plot 100 coordinates just to see if it follows that straight line pattern. Let's think about what it means in context. So 9.19 would mean if you buy 9 coffees, it should cost you $19. Is that true? We want to know if it's a solution. So if that's true, then it would be a solution. Well, think about how we got our coordinate point. We combined our x value with our y value, our input and our output. If I input 9, I should get an output of 19. So check. If you plug in 9 to our same function, 2x plus 3, do we get out 19? Well, plugging in 9 should have given us 18 plus 3, which is 21. 21 is not the same as 19. We did not get the correct output, so it is not a solution. 9 coffees does not cost $19. Pause the video here again and graph your function and then determine if your ordered pair of 8, 7 falls on your graph. Again, the answers will be at the end. The last part of this is being able to describe our meaning in context. This will continue to be a goal of ours throughout the next few lessons, as it's important for us to understand what is actually happening in these functions. So we have a couple questions in context here. How much would it cost for 12 iced coffees? And what would d of x equals 11 mean in this context? So first, if I want to know for 12 iced coffees, the coffees were my input. So I just need to take my function and plug in 12. So d of 12, I replace the x with 12. 2 times 12 is 24, plus 3 is 27. So if you bought 12 coffees, it would cost $27. And the last one, what would d of x equals 11 mean in this context? As we saw in previous lessons, we know the output. The output is 11, which means 11 is what it costs, just like 27 was what it costs above. So if we bought X coffees, it would cost $11. Now it's your turn again. pause the video and answer the last 2 questions on your side. We will check the answers in the next screen. Here are all your answers for your student does side. Check through them to see if you got the correct answers. If you got something wrong, you might want to go back to that section where we talked through it and figure out why the answer is what it is. In this lesson, we learned that creating a table involves evaluating the function for the domain. Once our function's evaluated, your domain and range can be written together as a coordinate. So for example, if we had a function of 4x minus 2, f of 1 would equal 2. Okay, so our domain value of 1 produced a range value of 2. Together, they make the coordinate of 1, 2, our input and our output. Doing this over and over and evaluating multiple domain values, we end up generating a list of coordinates, which we can then plot to show what the graph looks like. If we want to determine if a coordinate is a solution, we plug in the input and the output value and see if it makes a true statement. Okay, if it's true, it's a solution. If it's not true, it's not a solution. So here, 5, 16 would not be a solution because if I plug in 5, I do not get 16 as my answer. We can also use parts of our function to help describe our situation. For example, here in our 4x minus 2, we could say each carton of ice cream costs $4 and you have a coupon for $2 off of the total. So 4 per ice cream, take away 2 at the end. If I wanted to buy 5 ice creams, I would plug in 5 and my cost would be $18. And like we've seen before, if you are given the output, such as f of x equals 26, that would mean that your total was 26 for how many ever things that you ended up using. So after this lesson, do you now know how to create a table for a function? Can you use that table to graph your function? Can you decide if coordinates are part of the solution? And can you give meaning in context behind the parts of our functions? If you're not confident with any of these things, go back and find the learning target about that specific thing. Rewatch that part of the video to help solidify your understanding. And that is the end of lesson 4 on Introduction to Graphing Functions.